All of the problems that we've worked thus far have assumed annual compounding, that the interest has been compounded only one time per year annually. But certainly, interest can be earned or paid, compounded more frequently than just one time a year. Investments with semi-annual, quarterly, monthly, or daily compounding, that's commonplace. If we have a problem with more frequent compounding, then we have to adjust our methods. Our methods have to reflect that more frequent compounding is occurring. So to do that, we're going to let the variable m be equal to the number of times interest is compounded in a year. So if we have semi-annual compounding, m would be 2. For quarterly compounding, m is 4. Monthly, m is equal to 12. Daily compounding, m is 365. So we're going to have to adjust our methods. Now we need to think about a rate per period. Not a rate per year, but a rate per period, or a periodic rate. So we're going to take the stated interest rate in our problems and divide by m. That's what we enter into our calculators, that periodic rate, the interest rate divided by m. We are also going to have to alter time, the time that we enter into our calculators. Previously, n was the number of years. Now we have to start thinking about the total number of compounding periods. So we're going to take from our problems the number of years and then multiply it times m. That's what that product, years times m, is what we enter into our calculators when we have problems that have more frequent compounding. So before we look at a problem, let me pose this question to you. Will the future value of a lump sum be larger or smaller if it's compounded more often, holding the interest rate constant? Well, here's an example. It will be larger as the more frequently compounding occurs, interest is earned on interest more often. So if we have $100, we invest it for 3 years, 4%. This is not an annuity, it's a lump sum. Invest the $100 at 4%, we leave it alone. At the end of year 3, what will our $100 have grown to become? With annual compounding, we end up with $112.49. What if, on the other hand, same $100, 3 years, 4%, but the interest is compounded semi-annually? So we have 6 compounding periods, 6 6-month periods, and the interest rate, the 4%, is now a periodic rate. It's 2% every 6 months. With semi-annual compounding, our $100 will have grown to $112.62. So it is larger with more frequent compounding for this situation, for this scenario. Doesn't look like a lot, but if we were talking about $100 million, we'd be talking about more than just a few cents. So here are 3 separate problems that are worked for you. Problems 523, 24, and 525. You can find them in the video reviews. Probably be a good idea to try to work them on your own first and then watch the video reviews.